As a product manager, you're trying to deliver value to the company and to your users. So before embarking on a machine learning initiative, you need to really understand the problem you're trying to solve. And broadly speaking, your problems in the machine learning space can be categorized into 6 areas. Firstly, if you're trying to help users find the right thing when they search, this is a ranking problem. And Google, Bing, and other sites like Twitter, Search are all doing this. They're trying to sort things when you query so that the thing you're looking for is at the top. And ranking is a good candidate for machine learning because you really can't derive the logic for determining how to best rank something because there are too many variables involved and the weightings for those variables are difficult to determine, and they also change because things like trends can affect the weighting and the variables also. So machine learning is an appropriate way of solving the ranking problem. However, if you're giving users things they may be interested in without them explicitly searching for it, for example, where a user gets no search results at all for their search term and you provide something else that wasn't explicitly searched for, then this is a recommendation problem. And companies like Netflix and Spotify are examples of recommendations that are made by the company to the user based on the user's behavior. And these products are suggesting things to get the users to engage better with the product. But if you're trying to figure out what kind of thing something is, then this is a classification problem. And one of the oldest forms of machine learning that really achieved commercial success is the spam filter. And Gmail automatically classifies your email as spam or not spam based on the contents of the email. And Facebook's face detection of photos works in a similar way. And the fourth type of problem solving is a regression problem. And this is where you're trying to predict a numerical value of a thing, such as in our example, the value of a person's weight from their height. Another more realistic commercial example might be the estimation of a price for a home based on variables like the square footage and the number of rooms. So that is a regression problem. But if you're trying to put similar things together, then this is clustering in action. And Amazon's feature of showing customers also bought something is the most notable example of clustering. And then finally, there is anomaly detection. And this is where you find uncommon things. And most trending products featured in sites like Foursquare and Twitter and Facebook are examples of anomaly detection that surface things that are being tweeted or visited or talked about more than usual. We can also classify these problems based on the approach taken to solve the problem. And broadly speaking, there are 3 approaches to solving machine learning problems. And the first is called supervised learning, and the second is unsupervised learning, and the third is reinforcement learning. So let's take a moment to examine all 3, starting with supervised learning. In our previous lesson, as a nutritionist, we wanted to determine a person's weight from their height. And so we created a machine learning model by feeding the machine examples of people with details about their weight and height. And with this approach, we are using supervised learning because we are providing the machine with sample data that is labeled with the correct values for the variables that matter. And the fact that the output, which in this case would be the weight, and the feature values, which are the height of the person, are known and supplied to the machine, qualifies the data as labeled. And the algorithm then deciphers patterns that exist in the data and creates the model that can then reproduce the same underlying rules with new data. And supervised learning is probably the most popular form of machine learning out in the real world today, so we will cover that extensively throughout the course. And the second form of learning is called unsupervised learning. And in the case of unsupervised learning, we simply supply the machine with the data and it then uncovers hidden patterns and creates labels through the use of unsupervised learning algorithms. Now, in terms of which approach is best for which problem type, if we go back to our problem types, broadly speaking, problem type 1 through 4 are typically solved using supervised learning, and problem type 5 and 6 are solved using unsupervised learning. Now, there is also a third, more advanced type of machine learning approach, and that is called reinforcement learning. To understand how reinforcement learning works, let's take a look at an example. Google a few years ago acquired a robotics company called Boston Dynamics. And you may have seen some of their robots. They're both fascinating to watch and terrifying at the same time. Now, as you observe this robot, you'll see that the robot takes a big step forward and then might fall, and then the next time it takes a smaller step and is able to hold its balance. And the robot then tries variations like this many times, and eventually it learns the right size of step to take and walk steadily. And it succeeded. And what we're seeing here is an example of reinforcement learning. Reinforcement learning directly connects a robot's action with an outcome without the robot having to learn a complex relationship between its action and result. The robot essentially learns how to walk based on a reward, which is staying balanced, and punishment, which is falling. And this feedback is considered reinforcement for doing or not doing an action. And reinforcement learning, in a very simplistic definition, is learning best actions based on rewards or punishment. And another example of reinforcement learning was the game Go, where Google was able to build a supercomputer that beat the best Go player in the world. And there are three basic concepts in reinforcement learning. There is state, action, and reward. And the state describes the current situation. And for a robot that is learning to walk, the state is the position of its two legs. And for a Go program, the state is the positions of all the pieces on the board. And action is what an agent can do in each state. So given the state or positions of its legs, a robot can take steps within a certain distance. And these are typically finite actions an agent can take. For example, a robot's stride can only be, say, 0.01 meters to 1 meter. And the Go program can only put down its pieces in one of the 19 by 19 positions. And when a robot takes an action in a state, it receives a reward. And here the term reward is an abstract concept that describes feedback from the environment, and the reward can be positive or negative. And each of these concepts seem simple and straightforward. Once we know the state, we can choose an action that hopefully leads to a positive reward, but the reality is it's much more complex, which is why reinforcement learning is considered to be one of the most advanced forms of machine learning. Alright, now that you have a basic understanding of how machine learning works and the type of problems it solves and the different approaches for solving those problems, the next lesson will be a practical one where you get a chance to apply what you've learned and classify machine learning algorithms as supervised, unsupervised, or reinforcement learning. I'll see you soon. Bye for now.